This is the third lesson from our first physics unit, motion and forces, and lesson 3 will focus on just that, motion and forces. Right now you should have your lesson 3 notes in front of you, and make sure you are paying attention for those hidden talking points throughout the video. First, we must talk about what is a force. So lots of us have played sports, play sports. So anytime if you're playing sports, playing soccer, when you kick a ball or make a pass to a teammate, you apply a force to the object. A force is a push or pull that one body exerts on another. For example, in this picture, the diagram, this person is kicking a ball with a force in this direction. So when he kicks it, the ball goes flying up. Okay, the next part of this says forces aren't always obvious. You don't notice the force of the floor on your feet or the force of the atmosphere exerts on your body, but they are there. And that's why I have this picture. So if you imagine a little person right here, you have all this air above you is pushing down on you. Now you don't feel this, but it still means that a force is there. And the last part, letter B, says when a force is exerted on an object, it can cause an object to switch direction. Or if an object is standing still, it can cause that object to move. So now I'd like you to think of your own life and think for your first talking point of 2 examples of a force acting on an object, and if you could write them in the left-hand margin, that would be awesome. Thank you. And then we're going to move on to the different types of forces next. Now we're going to move on and talk about types of forces. The first types of forces are balance forces. Force does not always change a velocity. In the picture, 2 people are pushing equally and on opposite sides. So the net force is 0. So this girl is pushing equally this way, this girl is pushing equally that way, so the box doesn't move at all. Net force is the combination of 2 or more forces acting on an object. So these 2 girls' forces adding together are equaling up to a net force. Now I'm just going to get these out of the way, get this out of the way, and we're going to talk about what happens when we have an unbalanced forces. So this picture is a picture of an unbalanced force, and this picture is also an unbalanced force. Now, the first one is when 2 people are pulling in opposite directions, and one pulls with a greater force, the object will move in the direction of the larger force. For example, in tug of war, the team that pulls harder wins. So in this picture here, this person is pushing harder right here, so the box is going to move to the right. Letter C focuses on the bottom picture, and it says if 2 forces push in the same direction, the object moves with the force. Now next, in part 3, we're going to talk about something called inertia and mass. And we'll start with letter A. When an object is moving, it will continue to move in that direction until something exerts a force in the opposite direction and stops the object. This idea is called inertia. So if you can imagine these cars sliding on this clear ice right now, they're going to keep sliding until they either A, hit something, or B, the brakes are applied and they stop the car. In both cases, that's a force. But inertia is describing how they will keep moving until basically something stops them. So whether that's a tree or another car, something has to physically stop them from moving. So for letter B, the first part there, you should write that inertia, again, explains why when a car slides on this ice, it does not stop until it hits something. So there you have letter A and B. We're going to get rid of those. Next, we're going to talk about how size or mass affects inertia. And letter C says that different size objects have different inertia. Think about hitting a ping pong ball with a racket and then hitting a bowling ball with the same racket. The bowling ball takes much more energy to stop. So if you look at the picture here, this is a picture of a typical racket and ping pong ball. This is actually a picture of a tennis racket and a bowling ball. And you can see that the racket's snapping in half because it's not meant to take the force that a bowling ball has, because the bowling ball is much bigger. It has a lot more inertia than a tennis ball or a ping pong ball. The last thing for us to talk about is Newton's first law. And so right away you can write Newton's first law. So right here I'm circling with the pointer. Newton's first law states that an object in motion stays in motion until acted on by an outside force. And this is also called the law of inertia. So this is the same idea of inertia that we talked about in the last page. This law helps describe what happens in a car crash. In a car crash, a person in a car moving 50 miles per hour is also moving 50 miles per hour. When the car stops, any person not wearing a seatbelt continues to move forward at 50 miles per hour until something stops them. And so a lot of times this is how people slam into the dashboard, the steering wheel, and the windshield, because they're going to move because of the law of inertia until something stops them. This brings us to letter C. This is why seat belts are so important. Seat belts are important because they increase the time it takes a person to stop. When a crash happens, it takes 14 times the force of gravity to stop a person. A seatbelt lowers the force required to stop someone and also prevents them from being thrown from the vehicle. That's at the end now, but what I want you to do for your last talking point is, just like with the forces, I want you to think of 2 times that you've seen the law of inertia work in your life, and I would like you to write those down underneath letter C on this page. And that concludes the lesson 3 on motion and forces.